everyone, and welcome to this explainer. I'm absolutely thrilled you're here today because we have a genuinely fascinating topic to unpack. Now, if you've been following the AI space lately, you're probably feeling a little bit of whiplash, right? I mean, the sheer volume and pace of recent releases coming out of Google DeepMind has been nothing short of staggering. We're talking about an ecosystem that's basically evolving weekly. But instead of just reacting to isolated announcements, we're going to take a step back and look at the big picture. We're going to explore exactly how you actually build with Google DeepMind's Generative Media Stack. But before we dive into the future, I want to pose a slightly provocative question to you all. Are we building the wrong AI tools? In the developer world right now, there's this really common phenomenon that Paige, an AI engineer over at DeepMind, calls the anti-sprint. Essentially, if you look around and see absolutely everyone sprinting to build the exact same infrastructure workaround, well, it's often a giant red flag that you're building something that is going to be obsolete in a month. And this idea perfectly illustrates why. Think about it. Not too long ago, models had these tiny context windows, maybe 8,000 tokens. So what happened? The entire industry sprinted to build really complex vector databases to act as external memory. But then, the models just natively absorbed massive context windows. Boom, obsolete. Then, people sprinted to build giant external agent frameworks. But now, reasoning and agentic behaviors are being baked directly into the base models themselves. The foundational models are just natively absorbing all these complex capabilities. So rushing to build heavy wrappers is honestly often a mistake when the ground is literally shifting beneath our feet. To make sense of this shifting architecture, here is our roadmap for today. Number 1, the AI building paradigm shift. 2, multimodal cloud capabilities. 3, mastering generative media. And 4, local power with Gemma 4. Let's start building that modern AI tool belt.
All right, kicking things off with part 1, the AI building paradigm shift.
So what does this new era actually mean for us as focused creators? Well, it means a massive leap in architectural efficiency. We are finally moving away from piecing together fragmented, single-purpose AI models and stepping into an era of holistic understanding. And the core of this shift is absolutely crucial. Gemini is not, and I repeat, not just a text engine that happens to have vision bolted onto the side. It was built from the very ground up to be natively multimodal. That means it processes video, audio, text, code, images, all in the exact same embedding space, all at the same time. But the real paradigm shift here, it's the output. It doesn't just take that stuff in, it outputs it natively. It can spit out text, interleave it with generated images, write some code, and then just generate audio tokens on the fly. It understands and interacts with the world so much more like a human actually does.
Moving right along to section 2, multimodal cloud capabilities.
To see how this plays out in the real world, let's zoom up into the cloud layer and look at the highly scalable tools that are sitting right there in AI Studio right now. The Gemini 3.1 family is basically a toolkit structured to give developers total control over performance and cost. First, you've got Gemini 3.1 Pro. That's your heavyweight. It is perfect for deep, complex reasoning, multi-step agentic workflows, heavy-duty coding, the whole shebang. Then there's 3.1 Flash, which is that perfect sweet spot of speed and versatility, making it incredible for real-time conversational APIs. And finally, you have 3.1 Flashlight. This one is super lightweight and specifically designed to be highly cost-effective at massive scale, but it still magically retains the ability to analyze video and audio natively.
And guys, when I say cost-effective, I really mean it. 25 cents, a literal quarter. That is the cost for Gemini 3.1 Flashlight to chew through 1 million multimodal tokens. To put that into perspective, you could upload an entire hour-long video, tell the model to extract highly specific timestamped events, cross-reference all of that with Google search grounding, and your bill for that process is literally counted in pennies. That totally changes the math on what kind of AI applications are financially viable for us to build. While we're still up in the cloud, I have to mention this experimental world model called Genie 3. Okay, this is where it gets wild. It doesn't just generate a static video file. It generates an interactive, fully playable 2D world, frame by frame entirely from a text prompt. Imagine this. Paige prompted it for a pink sparkly squirrel wearing a pirate hat sitting on a boat in London's Regent's Canal. Genie 3 didn't just paint a pretty picture. It created a live environment where she could literally use her keyboard to make that little pink squirrel jump from boat to boat. And there's no traditional physics engine running in the background. It is just foundational models dynamically predicting the very next frame based on what the user does. It is completely mind-bending. Which brings us to Section 3, Mastering Generative Media. Having all these isolated cloud capabilities is awesome, for sure. But the real magic happens when you step into the Creative Suite and start pipelining them together to build full, immersive multimedia experiences. To show you how this looks in practice, Guillaume, DeepMind's generative media expert, built this phenomenal pipeline using the classic public domain book, The Wind in the Willows. Check out how this flows. Step 1, he feeds the entire text of the book into Gemini to act as the overarching context engine. Step 2, Gemini then prompts Nano Banana 2, which is their image generation model, to design perfectly consistent visual characters like the toad and the badger. Step 3, he passes those static character images along with chapter summaries into VO 3.1 Light, and it generates animated video clips of the story. And then, Step 4, he uses Lia 3 to generate totally custom background music that perfectly fits the mood of each specific chapter. He built an entirely automated, highly cohesive audiovisual pipeline, all springing from one single text file. I want to pause on that last step for a second because Lia 3 is a massive leap for audio. This is an API-accessible music generation model. It can create high-fidelity, full 3-minute songs, complete with actual lyrics, just from a text prompt. But it gets even cooler. There's a real-time DJ variant of Lia. Think about the potential here. You could build an app where the background music generates continuously, smoothly shifting its genre or tempo in real time, reacting directly to the user's live prompt or even their physical environment. Embedding dynamic audio generation right into an app unlocks totally unprecedented user experiences. And finally, Section 4, Local Power with Gemma 4. So far, we've been in the cloud. Now, we are pulling all of that power out of those massive data centers and bringing it right down to your local hardware. Gemma 4 is DeepMind's brand new open-sourced family of models. And within this family are what they're calling effective models, specifically the 2 billion and 4 billion parameter sizes. The word effective here refers to this absolutely brilliant architectural trick. The model's embeddings are actually kept in flash memory, and they are only paged in right when they're needed. It doesn't load the massive footprint into active RAM. This trick optimizes these models to run fully locally, completely offline, on surprisingly low-end hardware. We're talking an iPhone, a standard Android device, or even a basic Raspberry Pi. But please, do not let the tiny footprint fool you. These little models pack a serious punch. They feature built-in agentic thinking, native multimodal understanding, meaning yes, even the tiny offline model on your phone can understand audio and images, and incredibly strong code execution. Let's remember, just 6 months ago you needed a massive, screaming GPU cluster to pull this off. Now, those open weights can be deployed entirely locally. And the best part? That keeps all of your user data completely private right there on the device. To really grasp how wild this local setup has become, you have to hear about this demo from Ian on the Gemma team. It's mind-blowing. He took the larger Gemma 26 billion model. Now, this one uses a mixture of experts architecture, so it actually runs totally smoothly on a standard MacBook. He set it up as a master orchestrator, completely offline, zero internet access. That single local model spawned 10 independent sub-agents, handed every single one of them a different coding task to generate complex SVG graphics, and then seamlessly compiled all their work back together perfectly. You literally have an autonomous AI dev team living right inside your laptop. And it pushes even further into this concept they call local vibe coding. In another live test, Ian just asked the local Gemma model to build a playable web game from a basic tech spec. The offline model went to work. It wrote the HTML, the CSS, the JavaScript logic. But here's the crazy part. When the game threw a syntax error, the model read its own error logs, figured out what was wrong, actively edited its own local files to fix the typo, and successfully deployed a working game within a game. The entire loop, ideation, coding, debugging, and deployment happened 100% autonomously, 100% locally. So let's bring it all together. From the impossibly cheap, lightning-fast intelligence of Gemini Flashlight up in the cloud, to the dynamic music generation of Lia 3, all the way down to those autonomous coding agents running directly on your laptop with Gemma 4. The tech stack itself is no longer the bottleneck. These native models are absorbing all the friction that used to slow us down. So the only question left for you is this. The barrier is officially gone. What are you going to build? I really hope this explainer sparked some new ideas for you today. Keep learning, keep building, and I will catch you next time.